All right, let's find the side length of each of these cubes that form a cube with the given volume. So the side length needs to be the same for the cube. What number multiplied by itself 3 times would give us 8? Well, that would be 2 times 2 times 2 will give us an 8. For the next one, what number times itself 3 times would give us 27? That would be 3 times 3 times 3, which is 27. And for the last one, what number times itself 3 times would give us 125? That would be 5 times 5 times 5 is 125. These are all volumes of cubes. And the volume of a cube is length times width times height. These are called perfect cubes. So we're going to be finding cube roots. A cube root of a number is a number that when multiplied by itself, then multiplied by itself again, equals the given number. So I've written a cube root here. The radicand is 27. And notice I have 3 on the outside of the radicand, which means I'm looking for the number that multiplied by itself 3 times will equal 27. That would be 3 times 3 times 3. So the cube root of 27 is 3. The 27 is called a perfect cube. A perfect cube is a number that can be written as the cube of an integer. So we know that 27 is equal to 3 times 3 times 3, so it is a perfect cube. So we've already discussed the radical sign for a cube root. It has the 3 on the outside of the radicand, and the radicand is the number inside. This is what's important about working with cubes, and that is cubing a number and finding a cube are inverse operations. So what that means is if I was finding the cube root of 8 and then cubing it, I'm going to end up with my radicand. So if I do the work out, the cube root of 8 is 2 times 2 times 2, so it's 2. And now if I take 2 to the power of 3, that's also 2 times 2 times 2, which is 8. So they are inverse operations. Cubing and finding a cube are inverse operations. Okay, we've already done the first problem, the cube root of 8. The cube root of 8 is 2 times 2 times 2, which is 2. But one thing we have to consider when we're doing cube roots is that we sometimes might have a cube root that is a negative. So in this case, I know that 27 is a perfect cube, and that is 3 times 3 times 3. But for me to get a negative, I need to have a negative 3 times a negative 3 times a negative 3. Because negative times negative would be positive, positive times negative would be negative. So the cube root of negative 27 is going to be negative 3. Now, when we're faced with something like this, what we're going to do is split this up into 2 cube roots. That makes it a little bit easier because I know the cube root of 1, or anything that has a 1 in it is going to be a 1. And I also know the cube root of 64 is 4. All right, let's look at a few other examples. In this first one, I have the cube root of negative 343. And what I did is I used my calculator, because I don't know this one offhand. And on the calculator, it's going to have something like this as a symbol. And the first thing you're going to do is put in the radicand. So you add the radicand first. And then you're going to put what number you want to find the root of. So for this, you'd put 3. So I've already done this on the calculator. And I know that 343 is -7 times itself 3 times. So the cube root of -343 would be -7. Now when we're doing an expression, we're going to follow order of operations, and we're going to treat the radicand first, like parentheses. So I'm going to keep 18 minus 4, and I'm going to do the third root of 8, which I know is a 2. Then I'm going to multiply, because that's the next step we do in order of operations, and then subtract at the end, and we get 10. Now, the next one, I'm finding the cube root of 64, and then I am cubing it, which means these two operations are going to cancel each other out, and my result is going to be the radicand, which is 64. And 64 plus 43 would be 107. Evaluating expressions done the same way as we do any other expression. We're going to substitute in first my value for y, which is 64. And the first thing I'm going to do is say, well, I know that 8 times 8 equals 64, so I'm going to break that up already. And my cube root then, so I didn't even do the multiplication, is going to be 8 plus 64, which means I'm going to end up with a 72 here. And for the next one, we've got 2 times -3 minus the third root of 9 times -3. And this one I'm going to do the workout. 9 times -3 is -27. So I know the cube root of -27 would be -3 times -3 times -3. So it would be -3. And then I'll do my multiplication, which is -6. And this would end up being +3, and it would be a -3. Okay, we're going to find the volume of a music box that is shaped like a cube, and it's 512 cubic centimeters. Find the side length of the music box. So we know volume is length times width times height, but for a cube, it is side times side times side, or side cubed. They give us the volume is 512, so we're going to put that into our equation. And now I have to find the cube root of 512. Well, I did a little bit of pre-work ahead of time. I did 6 times 6 times 6, so the cube root of 216 is 6. And then I tried 8 times 8 times 8, and I got 512. So the cube root of 512 is 8. So I'm going to take the cube root of 512 and of my side, and I'm going to get the side length is equal to 8 centimeters.